Hello everybody, this is a tutorial for my Year 12 method students. Now what we're going to be doing is looking at solving simultaneous equations. These are mainly from the type you'll find in exercise 2f in the text. Now let's have a look at this one below here. So we have, let's see, I'll put it in blue. We have 2x minus y is equal to minus 3 and minus 4x plus 2y is equal to 8. So, alright, well let's see, let me decide here. I think what I'll do is I'll eliminate the x's. So if I try to eliminate x, I'm going to need to get an equal number of x's in this bottom equation compared to this top equation. So what I'll do is I'll multiply this equation by 2, because 2x times 2 will give me 4 lots of x. 4x's in the top row will cancel with 4x's in the bottom row. So if I multiply the top line by 2, that'll be 4x minus 2y is equal to minus 6. And in the bottom row, minus 4x plus 2y is equal to 8. Now when I add these two together, 4x and minus 4x will be 0, so I've done what I've said, I'll eliminate the x, but then minus 2y plus 2y, that also cancels out, so I get 0. And then if I add these two together, minus 6 plus 8 is equal to 2. Well, wait a minute, I've ended up with a statement that 0 is equal to 2. Well, that can't be true. This is a bit of nonsense. What we need to do now is think of another way maybe we can solve it and reconcile this difference so that we can figure out an appropriate solution. So what about if instead of trying to solve it algebraically, we try to solve it drawing graphs instead? So this is a linear graph. I can sketch this. I'll take the y across to the other side and take this 3 across there. So that would be 2x minus 3 is equal to y. Now that would mean the gradient is equal to 2 and the intercept is minus 3. So that would mean I'd have an intercept down there at minus 3 and my graph would go through like that. So there's y equals 2x minus 3. Now, what about this equation here? Well, if I take that minus 4x onto the other side, I'll end up with 2y is equal to 4x plus 8. And if I divide both of these by 2, y will be 2x plus 4. Alrighty, well that would mean the gradient would be 2 and the intercept would be 4. So that would mean my graph would go up here with an intercept at 4, and this would be the line y equals 2x plus 4, which is the same as this line here. Well, wait a minute, no wonder I don't get a solution. These two lines are parallel because they have the same gradient, and therefore they'll never cross. No wonder we couldn't figure out any solutions before. Now, let's have a look at the next slide. Okay, with this next slide I've tried to spell out what I'm trying to illustrate by making this presentation. If we have simultaneous equations where the gradient is equal in each equation but the y-intercepts are different, what we'll have is there are no solutions to that set of simultaneous equations. So the lines are parallel and they'll never cross. Okay, so if you get a set of simultaneous equations and you can't find a solution, it could be because the lines are parallel and they never cross. Let's have a look at this next problem, which kind of sets up a more difficult kind of a scenario, a better scenario that you'll need to examine when we complete 2f. Okay, now here we have a set of simultaneous equations. Here's one equation here, here's another equation here. Find the value of m, so in here and here, where the simultaneous equations have no solutions. So let's take equation number 1 here and figure out the gradient in that, and equation number 2 and figure out the gradient for that. So if we took, with this one, 3x minus y is equal to 1, so if we took the 1 across to there and the minus y across to there, we'd end up with y, 3x minus 1 is equal to y. So that would mean the gradient would be equal to 3 and the intercept would be minus 1. Now for 2, if we took the mx across to the other side, we'd end up with 2y is equal to minus mx plus m plus 1. So we'll divide by 2 on both sides, so minus m over 2x plus m plus 1 over 2. So the gradient would be minus m over 2, and the intercept would be m plus 1 over 2. M plus 1 over 2. Now, if this is equal to this, then the lines are probably parallel. So if we said this gradient, 3 is equal to minus m over 2, and we took the 2 up to the other side, we get 6 is equal to minus m, and m would be equal to minus 6. Now if m was equal to minus 6, this line would be parallel to this line. That would mean we could potentially have a system where there are no solutions. Now what we can do is just check that. Alright, let's check and see whether we were on the right track. Now if we take this minus y across to there and this 1 across to there, we'll have 3x minus 1 is equal to y. So that would mean y would be 3x minus 1. So the gradient would be 3 and the y-intercept would be minus 1. Now if we substituted m is equal to minus 6 into this one, that would be minus 6x plus 2y and minus 6 plus 1. Now that would mean if we took this 6x across to the other side there, that would be 2y is equal to 6x minus 5. Now if we divide it by 2 on both sides, what we end up with, well, 6x over 2 is 3x and minus 5 over 2. So that would mean the gradient was 3 and the y-intercept was minus 5 over 2. So you can see these lines, this one and this one, are parallel. They both have the same gradient but a different intercept. So just like before, we have a pair of simultaneous equations where there are no solutions when m is equal to minus 6. Alrighty, well I hope that helped. Have a go at some of the questions from 2F, and if you have any troubles, see me in class.